Definition and example. This section will help you accomplish the following. State definitions of differential equations, solutions, orders of equations, mathematical modeling, initial conditions, and initial value problems. And distinguish differential equations of various types by examples. Definition. A differential equation is any equation, anything with an equal sign, involving derivatives of an unknown function. Example 1. dy dx equals 3x. X is the independent variable. Y is the dependent variable and is the unknown of the equation. This unknown is called the solution of the equation. To solve the equation is to find the solution of the equation. Another example of a differential equation is dy dt equals 3y. A verbal translation of this is the rate of change of y with respect to time t is equal to 3 times y itself. This is an example of an exponential growth model used for population growth models and continuously compounded interest models. More about models to come later. Question 1. What are the differences between equations of example 1 and 2? Answers. The independent variable x has changed to t. X on the left-hand side has changed to y. The change in 1 is insignificant in the solution method, but the change in 2 is significant in the solution method. Definition. The order of the equation is the order of the highest derivative of the unknown function involved in the equation. Example 3. The second derivative of y with respect to x plus 5 times dy dx minus y cubed equals tangent of x. This equation is second order because the highest derivative involved is the second derivative of y. Question 2. State the order of the following equation. Dy dt plus xy equals tan x. This is the first order equation because the highest derivative involved is of the first order. We will only investigate the first order equation in this tutorial. Here's another example of a differential equation. dv dt equals 5t squared plus 7. Differential equations historically arose from laws of physics. Chemical, biological, and financial processes and laws are also modeled by the differential equations. Modeling the real-world problems by using mathematics is known as mathematical modeling. Question 3. What is a possible interpretation of the equation of example 3 as a model of some physical circumstance? dv dt equals 5t squared plus 7. Answer. Think of v as the velocity of a particle moving with the acceleration a of t equals 5t squared plus 7. Since a of t equals dv dt, this gives us our differential equation. Differential equations are often used to predict what will happen in later time, knowing the values of the unknowns initially. Definition: a differential equation coupled with an initial condition or conditions is called the initial value problem, IVP for short. The equation in example 4, coupled with the initial condition, dv dt equals 5t squared plus 7, and v of 0 equals 17, is an example of the IVP. The task is to find the unknowns, or the solutions of the differential equation, IVP or otherwise.